In this session, I'm going to teach you the coding part related to the logistic regression. So let's import the basic package libraries that we require for performing logistic regression. So let me import NumPy. We need pandas library as well. We need matplotlib. And also we need a Seaborn library for visualization. We need a sklearn model selection. In that, we need to split the data. So for that, we import from sklearn dot model selection. From this library, we import train test split. And also we need a standard scalar for scaling the data. So from sklearn dot pre-processing import standard scalar. We also need to use logistic regression algorithm. So let's import that as well. So from sklearn dot linear model. In this sklearn in linear model, we'll import logistic regression in this case. Previously, we had imported linear regression. Now we are importing logistic regression. And also we need metrics as well from sklearn import metrics. We need this metrics for finding the accuracy as well as precision and recall score. Let's import warnings as well so that we can filter out warnings. Import warnings, warnings dot ignore filter, sorry, warning dot filter warnings of ignore. Okay, so we have imported the basic packages that we are going to need for performing logistic regression. So now let's import data set. So here is the data set that we have. So the data set we have is a social network advertisement data set where we have user ID, gender, age, and estimated salary. So we have to predict the purchase. So depending on this independent variable, we have to predict if a person has purchased or not. Okay, this is social network advertisement. So let's import this. So we'll take this, copy the path file. Data set is equal to pd.read csv. Let's see the data set that we have. Okay, we have user ID, gender, age, estimated salary, and purchased. Okay. So now let's extract variables from this. Extracting variables. So let's extract a column. This is zeroth column, first, second, and third. Let's extract column 2 and 3 in our x variable. and let's extract column purchased in our y variable. Okay, so x is equal to data set of, so data set dot ilog index location of. So we need all the call rows and we need specify a number of columns, that is 2 comma 3. Okay, need only 2 comma 3. And let's print x. So we have got age and estimated salary. This is our predictors. So let's print. So let's take array values. So we have got our value in the form of array. Now let's extract the dependent variable y. So y is data set dot ilog index location. Ilog is for index location. Okay, and let's pass. We want all the rows, and we want only the last column. Um, Last one. Let's pass it. Check if it works. Yes, let's pass the a values. Let's print y. Okay. So here are the values of y. That is the dependent variable, which is the purchased. So what we are going to do is that we have taken age and estimated salary as our predictors, and we are based on these predictors. We will see if a user has purchased the product or not. Okay. So if the user has purchased, it will say 0. If the user has not purchased, it will be 0. And if the user has purchased, it will be 1. So let's plot the correlation heat map to see the correlation. So for that, I have Seaborn library SNS heat map of data set dot correlation. Okay, so we have got, let's include values inside this, and not is equal to true. Okay, let's change this color as well. So CMap is equal to yellow, green, blue. Okay, so you could see that we have, we can see if there is any multicollinearity between independent variables. So we can see there is no multicollinearity, like age is not having any much relationship with estimated salary. There is no dependency, so there is no multicollinearity. So you could see that in the dataset dot correlation, we don't have the gender column because heat map only does for those which is a numerical value. If you want gender as well, then you need to convert that into you have to use label encoding or one out encoding. You have to convert it to numerical values by using label or one out encoding. Okay, so this is all about the heat map. So if you see the purchased is having a 62% dependency on age and 36% dependency on the estimated salary. So, and also we could see that if age is higher, the salary will also be higher as well. Sometimes, maybe not, depending on the data. Okay. So now let's do the splitting. Okay. So let's split the data into train and test. So we have X train, comma X test, Y train, Y test. Equal to train test split. So we are using this train test split only because we have imported train test split here from our sklearn model selection library. So let's do that. Train test split of, so we have to pass X and Y, the independent and the dependent variables over here. So after passing that independent and dependent variable, we have to pass the test size. Test size comes around. Let's pass it in a fractional part. Okay, we have been passing it in a decimal part. Let's pass test size to be fractional. Like let's consider 1/3 of the data is our test data. Okay? So you don't have to pass the train size. And automatically, the machine will take 2/3 as your training data, and you have to fix the random state is equal to some value, so that when you rerun the program, the splitting happens in the same way. Okay. Okay. So let's move to the next part. So okay. So now we have splitted the data in training test. Now we have to do feature scaling because from the data set you could see that in the social network data set you could see that age lies between 19 and somewhere in 70 maybe, and salary is from 10,000 till 50 side 1 lakh maybe. So you could see that the units are different, like okay, the range of values that lie is different. So we have to transform the data such that both lies in the same scale. Okay, so we use standard scaler, we scale down the values. For scaling down the values, we have to do fit transform, where fit will take the median mean and standard deviation of this, and it will automatically convert the values in the Z scale. And similarly for estimated bias study as well. So it will calculate mean and standard deviation, and it will calculate in the Z score way, and you will have values lying between -3 and 3 for 99.97% of the values, -9 and 3 and 3 it will lie, since it follows a normal distribution. Okay, we haven't checked any outliers over here. Um, don't worry about that for now. Let's do feature scaling for now. So this time, so we have imported standard scaler, right? So from data scaler and that pre-processing, we have imported standard scaler. It's used for scaling the data. Okay, so standard scalar is equal to, let's assign the variable with standard scalar. Standard scalar. It's right. Okay, now let's do the. So we have taken explain. So what we are going to do is that we are going to scale the data. Standard scalar. We'll pass extrain. So extrain consists of only age and estimated salary, because we have access to only column 2 and column 3 over here. So age and estimated salary will be scaled. So we'll pass extrain over here. And similarly, you need to have to for the testing it test data as well. X test is equal to standard scalar of x test. Okay. So you have to pass the method over here. So you have to do fit transform over here. Okay. Fit transform. You have to pass x train over here. And similarly, since you have already fitted the model with the performing fit, so you will have the mean and standard deviation for this. So you just have to transform the data now. Transform of X test. We're doing only transform because we have already performed fit for standard scalar, right? So when you do fit for any method, it has already trained with that model. So already it has got the mean and standard deviation. So we are using the same mean and standard deviation for the test data as well. Okay, so we're not taking fit over here. So we don't want the standard deviation or mean of this testing data. We want it from the training data only. Okay. So now let's run the code and check. Okay. What kind of error we got? Standard scalar. It should be LER. Okay. Let me run again. That's the error. Let me check. So let me run the data set again. So let's check now. Let's run this code now. So here we have just scaled the data of X train and Y train so that our salary as well as the age has the same scale, lies in the same scale. So now let's check the X test data now. So this is our X test. Okay, it's fine. So now let's perform instantiating and fitting the model to training the data set. For that, we have to import logistic regression, which we have already done. So here we have imported the logistic regression algorithm. So now let's give a name for that. A logistic regression is equal to logistic logistic regression. Okay, so we have instantiated. Let's do the fitting of the model. So logistic regression dot fit of X train, comma, this should be underscore, okay? Sorry for that. X train, comma, Y train. Okay, let's run this code. Okay. So, so I wanted to tell you about the standard scale, this fit transform again. So what happens is that during feature scaling happens after splitting because if we do it before splitting, since scaling takes account of all the data points and each data is transformed based on overall data, in a way we are exposing all the data before splitting. Okay. This will lead to data leakage. So leakage of data happens if you do scaling before splitting. That's why we have splitted the data here and then we had done the feature scaling. So you don't want your model to remember your data and performing based on the remembering and not learning. Okay. So you just want your model to not learn and you don't want your model to remember things. Okay. It happens that your model performing good, but once it's unseen data will come, the model will not perform. This is what happens when you have leakage in data. So if scaling is required after splitting the data. If you do space feature scaling before splitting, okay, before splitting, if you do feature scaling, then you're scaling your training data. That means you are doing it only part of that. After splitting, if you are doing, okay, after splitting, if you are doing the feature scaling, then you are training, then you are scaling your training data. That means you are doing it only for that part, okay, for this part only. So you don't want contribution of the test data in that case. So here fit transform is used for model pre-processing and coding like that. So here what happens is that fit will calculate the mean and standard deviation and then it will transform the data according to the Z-score formula. And then what happens is that, so this is all about the feature scaling part. So when it comes to logistic regression, so logistic regression is a linear model because it belongs to a line just that the line is from 0 to 1. Okay. So we have already seen that the line is from 0 to 1. And after that, we filter based on the threshold. So the threshold is like we have given threshold with 0.5. So whatever values lie above 0.5 will be considered as 1 and whatever value lies below threshold is considered as 0. This is how a logistic regression model works. Okay. So actually the thing is that we have to pass random state over here as well. Random state, we will pass it as a 0 something. Let's 10. Let me pass it as 10. Okay, so the random state is used for the reason that it is repeated. Otherwise, randomly it will change and might result the result may differ. Okay, so that's where we are fixing that random. That's why we are fixing it. Okay, so the random state in here, if you take the random state, the random state hyperparameter in test split function controls the reshuffling process. Okay, with random state is equal to null, we get different and test set across different execution. When you run this without random state, you will get different 10 and test split. Okay, but when you fix it with some value and when you run again with the same value, we get the same 10 and test set across different execution. Now, now let's come to the prediction for test data set. Okay, so prediction for test data set. So that is Y prediction. Y prediction is equal to logistic regression dot predict of X test. Okay, so it's small x. So let me see Y prediction here. So these are the Y prediction values. Let me see the Y test. So these are the Y test values. So you could see some values might differ from here. See here, this prediction is 0, but actually is 1. Okay, and somewhere here also it might change. Let's see. Here you could see it's 1 and our prediction is 0. So there are some errors. Okay, I mean there are some predictions which are wrong, but we want high precision and high recall score. Yes, then only we will say that our model is performing better. So now let's come to the visualizing the training set result. So for visualizing the training set result, there is a long code. It's a lengthy code. I want you to learn by your own because you know Python, right? So you might understand that. So let me paste it over here. I have taken everything. Okay. So it was from here. Let's see. So we'll run this code. So this is for the visualizing the training set result. When you run this code, you will get threshold value, and value above threshold will be considered as 1, and value below threshold will be considered as 0. Okay. So let me check if X set is X10. Okay, X10 is fine. Y10 is also fine. X10 and Y10. Fine, right? We have passed X10 and Y10. Okay. Let me run this code. So this is the visualizing the training set result. So see that. So this is the threshold value, and whatever value lies above is the it is above. It should be 1. That is prediction is 1, and whatever lies below this threshold it should be 0. But you could see some of the predicted values. So this is the prediction values. Like some predicted values are false. Like you could see this is blue. It should have been green. This should be green. This should have been green. This should have been green. And here also there are some false prediction that had happened. See, this should have been green. This should have been blue, blue, blue. So there are some wrong predictions. Okay, fine. Okay. Now let's do the same for test result as well. Okay. So we have the same code, same. I think it's the same code. You just have to change some parameters for testing, uh, visualizing the testing results. So when you run this code for this is for testing. Okay, X test, Y test have passed. Okay, so I hope you learn this code by your own because this is just a Python. Okay, so there is nothing big in this thing. It's just a Python code. So for the testing data set, the logistic regression, you could see there are some mismatch happen, mismapping, like some of the values that lies above threshold are in yellow and some of the values that lies below threshold are in red. So yes, we have some false values prediction. That is, we have some pretty wrong prediction. There is some false positive and false negative values that are present. Here also there are false positive and false negative values. To check those false positive and false negative values, how many false positive, how many false negative values are there, and how many true positive and true negative values are there. For that, we will build a confusion matrix. So from scalar dot matrix, import confusion matrix. So we have imported the confusion matrix over here. So we had not imported over here. So we have imported over here confusion matrix. So let me assign conf into confusion matrix, conf matrix. Conf matrix is confusion matrix. Okay, so confusion matrix we have. So in this confusion matrix, we have to pass X test and Y test. Sorry, it should be Y test and Y prediction. So see, here is our Y test and here is our Y prediction. So we will get to know the four parameters, that is true, negative, true, positive, false, negative, and false positive. Let me pass that. It is Y test and this should be Y prediction. So let me bring the confusion matrix. You could see that. So how you read it? Let me explain using an heat map. Okay, let's do an heat map. SMS dot heat map of confusion matrix. Annotate is equal to, so we need group values inside. Okay. So how you read? So this is 0. This is true negative, and this is 1. This is true positive. Okay. So how you read is that this is the actual value is in the top and the predicted value is over here. So actual is negative, predicted is negative. So there are two negative is 74 and true positive is 40. Okay. Then here it is negative, here is positive. Okay. So actual is, what is the actual? Actual is positive and predicted as negative. So actually predicted as negative means this is false negative. Similarly, this is false positive. Okay. This is how we have to do. So, and we have accuracy. So accuracy is nothing but how many times you have predicted correctly. So true positive is 40 and true negative is 74. 74 plus 40 divided by length. That is 74 plus 7 plus 40 plus 13. Length of I test is equal to total number of predictions. Okay. So the accuracy score comes out to be 85%. But we don't consider this. We have to consider precision and recall score for predicting the model's accuracy. So and the misclassification rate is nothing but how many times we have predicted wrong prediction. So that is false negative and false positive. So it comes out to be 13 plus 7 by length of I test. So if 15% times we have predicted false. Now what you could do is that now let's print the accuracy score. So in metrics, we have metric dot accuracy score. Okay, metrics dot accuracy score of, we have to pass here just Y test and Y prediction. So our accuracy score comes out to be 85%. Similarly, let's try to find the precision score as well. Tricks dot precision score comes out to be around, let's pass it, y test, comma, y prediction. Okay, so our precision also comes around 85%. Okay, so precision to whatever, how many times you and we got that. So how many times you have predicted the positive cases is the difference. Okay? So now let's print the recall score as well. So recall score comes to recall score, y test, y prediction. So recall score is less compared to that precision score. So we might have, we know that recall score is high because we have high false positive rate. Okay, we have high false positive rate. Because of that, we have recall score as high. Recall score is less. Okay, and we have less false negative score. That's why our precision score is high. I hope you understood. Now let's draw the ROC and AUC curve. Okay, AUC is nothing but the area under the curve. ROC AUC curve. So the ROC is receiver operating characteristics. Let's draw the curve. So we are going to draw receiver operating characteristic curve. So before that, we need Y prediction probability. That is Y probability, which can be find out using the model logistic regression dot predict proba. Okay. Then we have to pass predict probability of X test, X train, sorry, X test. Okay. So we want the testing data probability, and you want all the rows, and you are going to access only the first column. Okay. So the first column is going to give second column. So the second column is going to give the prediction probability. Okay. So now we want the false positive rate, true positive rate, and also there will be some parameters that are going to get. So let's pass underscore. So now we will pass here metrics dot wait a second. So in metrics we have ROC curve. So we pass Y test and Y prediction. Y test, comma, Y prediction probability. So we will get false positive rate and true positive rate. Now we now need the area under curve. So for that, we will pass matrix dot. So AUC, ROC, AUC score, right? Is it ROC, AUC score? Okay. We will pass false positive. So for ROC, AUC score, under that we'll pass Y test, comma, Y test, comma, Y prediction prob. So we have got our area under curve now. So now let's plot the figure. So PLT dot figure. So let's increase the fixed size. Let's take it 12 comma 10. Okay. And now let's have PLT dot legend as well. Legend of location is let's see. Let's legend will pass location 4. That is top bottom right, and we'll have plt dot title So I actually haven't mentioned the figure, right? So sorry for that. plt dot plot plt dot plot of. So we are plotting for false positive rate versus true positive rate, false positive rate versus true positive rate, comma label. You want label as area under curve. Area under curve is equal to less string of area under curve. Okay. So we want the title to be receiver operating characteristics. plt.x label of false positive rate and a plt.y label true positive rate. Let's print. Okay, name prediction probability. So where is the mistake? Let's check it. Prediction. Let's see, this should be y predict probability. So now let's print. Okay. So this is the ROC curve that we have got. So you could see the area under the curve is around 92.8%. So it's a good curve. I mean, we have a good uh, prediction values for our data set since it's more than 90%. So what you can do is that use gender column for prediction. So we have our gender column. So for that, you have to first do the encoding, do the label encoding and convert it into numerical value. Then after doing label encoding, you could do that is use gender column for prediction, then plot the PR curve as well. Okay. So we have plotted receiver operating characteristic ROC curve, and we have calculated the area under the curve for our ROC curve. So you know the concept of PR curve, and also try to find the F1 score. So F1 score is harmonic mean precision and recall. So we have our precision score 85% and recall score 75%. Just it is 2 into precision score into recall by precision score plus recall score. Just calculate that as well. So this is the end of this topic, logistic regression. Hope to see you in the next session. Thank you.